Hello everyone, this is Miss Lindsay. Today we're going to talk about section 15.5, which is an introduction to probability. The probability of an event is the likelihood an event will occur. The probability of an event is a number anywhere between 0 and 1. So again, you can kind of think of these in terms of percentages. 0% it could occur, or 100% chance it could occur, and anywhere in between. So go ahead and pause, answer the questions in the next two examples, 1 and 2, and then check your answers. Okay, so number 1, probability a Lake Forest Lake Bluff phone number will have 10 digits is 1, so 100% chance. And 2, the probability that a side of a triangle will measure -5 is 0, so a 0% chance. The probability that an event will occur can be determined by the ratio number of desired outcomes over the total possible outcomes. This, what you see in parentheses here, P in parentheses A, that is red. The probability of A. So the probability of A occurring would be the number of desired outcomes over the total possible outcomes. So let's take a look at example 1 here. What is the probability of randomly selecting a red king from a standard deck of cards? So we want to determine probability of getting a red king. Well, we know the total possible outcomes for the denominators, there's 52 cards in the standard deck. Out of those cards, we know that there are 4 kings, but we want red kings, so that would be 2. And let's always go ahead and reduce, so that would be 1 over 26. So there's a 1 out of 26 probability that will occur. Example 2, what is the probability of drawing a spade from a deck of 52 cards? Again, notice that is always going to ask you for the probability on these types of problems. So probability of drawing a spade, again, we know there's 52 cards in the standard deck, so that's our denominator. There are a total of 13 spades. That means 1 out of 4 chance. Go ahead and pause and do number 3, and then push play to check your answer. Okay, so number 3, the answer of probably rolling an odd on one roll of a die is 3 out of 6, which is a half, because we have the numbers 1 through 6 on a die, and the numbers 1, 3, and 5 are odd. On example number 4, suppose 3 cards are drawn from a deck of 52 cards. What is the probability that all 3 are clubs? Now this one is going to vary slightly from our previous example because we are drawing multiple cards. So when we are trying to draw 3 clubs, yes, we know we have 52 cards in our standard deck, but we need to draw 3 of those. So we're going to do 52, choose 3 as the denominator. In the numerator, we know we have 13 clubs. Of those 13, we want to draw 3. So we'll do 13, choose 3. So we're using combinations because we're doing a multi-draw from this deck, which gives us 11 over 850. But let's go ahead and step back to problem 3. This problem here can also be done in the same manner as what we did in the previous one. So the probability of drawing an odd, we have, of an odd number on one roll of a die. This would be, we have 6 numbers on a die. We are rolling 1 number. And then the numerator, we have 3 odd numbers, and we want 1 odd number to come up, which would give us the 3 over 6, which is a half. So it's the same idea, but because we're only drawing 1, or we're only wanting 1 number on our die, we do not have to actually do the combinations like we are forced to do in problem number 4 when we have a multi-draw type scenario. Number 5, what is the probability of rolling a sum of 11 with 2 die? So in our case here, probability, we want to roll a sum of 11. Well, let's think about this first. What are the ways that we can actually come up with this sum of 11 on a die? Again, knowing that the numbers are 1 through 6 on one die? Well, we have the options of 5 and 6 or 6 and 5. So we have two options to get 11. And again, we're rolling 2 here, so we have to think about combinations in the denominator. We have 6 sides on one die, and we're getting 1 selection, so 6 choose 1, times 6 choose 1 again. And again, by our fundamental counting principle, we would multiply those together. So let's go ahead and plug that into our calculator for the time being. So we'll have 6, go to Math, PRB, combinations. So we get that to be 6. So it will be 2 over 6 times 6, which will give us 2 over 36, which is 1 over 18. Moving on to the next example, or last example, a bag contains 6 blue, 10 green, and 4 white marbles. 6 are drawn at random all at once. What is the probability of getting 3 blue, 2 green, and 1 white marble? So again, our total amount of marbles, if we add those up, 6 plus 10 plus 14, we get a total of 20 marbles, and we're selecting 6. That's our possible outcomes. And the numerator, though, of those 6 blue, we want 3. Of the 10 green, we want 2. And of the 4 white, we want 1. Again, according to our fundamental counting principle, we would multiply those, and we would get 30 over 323. Okay? And this concludes section 15.5.